So we start with problems on function definitions. Let A is 1, 2, 3. B is, you will get one definite question on this. A is 1, 2, 3. B is minus 1, 0. And they have defined a relation between A to B in this form. R is equal to ordered pair 1 minus 1, 1, 0, 2 minus 1, 3, 0. Is R a function from A to B? You have to find out whether the given relation is a function or not. So we have to just try to represent in the form of pictorial representation. First do that arrow diagram. Then we will understand by looking at the diagram whether it is a relation, which relation R is a function or not. So already I have told that what kind of symbols are allowed here.
Greater than.
Yes, greater than symbol. Greater than symbol is allowed. So there is one greater than symbol here. Okay. One more greater than symbol. But there is also a less than symbol here. That's why this is not a function, because the one image, one element is mapped to minus 1 and 0. It cannot have more than one image. But an element here can have more than one pre-image. So look at that, 0 can have two pre-images, and similarly minus 1 can have two pre-images. But on the other way, 1 is having two pre-images. It's not entertained. 2 is having only one image. That's fine. 3 is having only one image. That's also fine. But only this is not paid in case of functions. So it is only a relation but not a function. Similarly, we take another example. Let A is equal to 1, 2, 3 and B is equal to minus 1, 0. And S be a relation from A to B defined as 1 minus 1, 2 minus 1, 3, 0. You have to find out whether it is a function or not. So S is defined here with this diagram. And look at this individual element and try to have a connectivity mapping between the elements. 1 to minus 1, there is a relation. Yes, there is a relation. 2 minus 1, there is a relation. So 2 to minus 1. Then 3 to 0. 3 to 0. So if you look at this, you have a greater than symbol here, but not less than symbol. So if the entire diagram has only greater than symbol or any line greater than or equal to symbol is also allowed. In that case, it is a function. Therefore, S is a function from A to B. On the other way, how do you say this? Every element here is having a unique image. 1 is having only one image. 2 is having only one image. 3 is having only one image. And 0 is having one pre-image. Minus 1 is having two pre-images. More than one pre-images is allowed in the function. Therefore, this is called as a, S is called as a function here. So with that, we are moving on to next kind of problem. Let A is equal to 1, 2, 3, 4, 5, 6 and B is 6 to 10. If a function f from A to B is defined by, and f is defined as this way. So what is our role to find out? Determine f inverse of 6, f inverse of 9. That first we have to, in the first part. After finding these two, you should also find out if V1 is equal to 7, 8, V2 is equal to 8, 9, 10. Find f inverse of V1, f inverse of V2. For finding these two, you should recall the definition of the range and finding out the f inverse in that particular diagram. So we will start with first f inverse of x. As per the definition, f inverse of x is equal to x belongs to A such that f of x is 6. So how do you define a mapping? A is here, B is here. B can be written as f of A, correct? F inverse of B is written as A, fine? So you are trying to find this F inverse of B. So pre-image for B you are trying to find. So what is the pre-image for B? You need to check in the relation or in the ordered pair where is the 6 in the second position. Look at this. For finding this, you have to look into this because 6 is in second position and 6 is having the pre-image as 4. 4 is having an image called 6. 6 is having a pre-image called 4. Therefore, F inverse 6 can be written as 4. In the similar way, F inverse of 9 has to be computed. Compute that also. F inverse of 9, where the 9 element is there in the second position. Yes, in these two elements it is there. So it looks like 5 and 6 are mapped to 9. So you are trying to find F inverse here. F inverse of 9 is 5. F inverse of 9 is 6. There are two elements. So 5 and 6. In the similar way, you need to find out for the subset also. Subset is defined, it's not a single element, it's a collection of elements. The way I have shown for single element, you have to do for all these elements. Take first B1 and check for these two elements and combine all the solutions. That will be the answer. Similarly, do it for B2. And I want you to try by yourself.